Welcome to 2.7 Graphing Inequalities. We're going to learn today graph linear inequalities and absolute value inequalities. So we're going to start with a vocab concept. So the boundary is a solid or dashed line that serves as the edge of the shaded region where the inequality is satisfied. So this is the example that we have here, y equals 2x plus 1. It's a solid line and it's shaded on one side, not both. So step 1, we determine whether the boundary should be solid or dashed. Graph the boundary. Step 2, we choose a point not on the boundary and test it in the inequality. Step 3, if a true inequality results, we shade that region, the point that contains the test point. If it's false, then we shade the other region. So example 1 here, dashed boundary. So we're going to graph 2x plus 3y is greater than 6. So the boundary is the graph 2x plus 3y equals 6. Since the inequality symbol is greater than, the boundary will be dashed. We're going to use the slope-intercept form. So we're going to solve for y, and we get y equals negative 2/3 x plus 2. So we're going to subtract 2x divided by 3. So again, our equation is y equals negative 2/3 x plus 2. Now we're going to test the point 0, 0. The point 0, 0 is usually a good point to test because it results in easy calculations. So we're going to do 2 times 0 plus 3 times 0 is greater than 6. 0 is not greater than 6, so we're going to shade the region that does not contain the point 0, 0. So we're going to graph the line negative 2/3 x plus 2. It's dashed. And then we're going to shade the point, or we're going to shade the region that does not have the origin in it. So above. Okay, so that's example 1. Example 2 is a solid boundary. So a mail order company is hiring temporary employees to help in their packing and shipping departments during their peak season. We're going to write an inequality to describe the number of employees that can be assigned in each department if the company has 20 temporary available. So the idea here, we're going to let P be the number of employees assigned to packing, and let S be the number assigned to shipping. Since the company can assign at most 20 employees total to the two departments, we're going to use a less than or equal to symbol. So P plus S is less than or equal to 20. P is the number of packing, S is the number of employees shipping, and at most 20. We're going to graph this inequality. Since the inequality symbol is less than or equal to, the graph of the related linear equation P plus S equals 20 is solid. This is the boundary for the inequality. We're going to test the point 0, 0. 0 plus 0 is less than or equal to 20. This is true, so the origin is included. We're going to shade the region that contains the origin. Since the variables cannot be negative, shade only the region, only the part in the first quadrant. So this is what our graph is going to look like. We graph the line x plus y equals 20. It's solid, and we're going to shade underneath, including the origin. So the last question, can the employee assign 8 employees to packing and 10 employees to shipping? The point 8, 10 is in the shaded region, so it satisfies the inequality. The company can assign 8 employees to packing and 10 to shipping. The answer is yes. Example 3, absolute value inequalities. So we're going to graph y is less than or equal to the absolute value of x plus 1. Since the inequality symbol is less than, the graph of the related equation of y equals the absolute value of x plus 1 is dash. We're going to graph the equation. We're going to test 0, 0. So y is 0. So 0 is less than the absolute value of 0 plus 1. So this is true because 0 is less than 1. We're going to shade the region that includes 0, 0. So we're going to graph the absolute value inequality, which is the absolute value of x, and then we're going to shift it up 1. And we're going to graph everything below it because the origin was included. So that is a little bit about graphing inequalities. Good luck on the practice.